Again, good morning or good afternoon. My name is Ben Said. I'm the Associate Product Manager for Pavement ME Design at AASHTOWare. Welcome to the AASHTOWare Pavement ME Design webinar series. This webinar will be recorded and published later next week. A couple of housekeeping items. You are unable to unmute yourself during the webinar to ask questions. However, either at the bottom or the top of your screen, depending on the type of device you're using, you'll see a Q&A box. Feel free to submit your question within the Q&A feature. Someone will either type a response back to you, or we have two Q&A sessions set up, one during the first third of the webinar and another one at the end of the webinar, and we'll be able to answer your questions then. There will be a couple of polls throughout the webinar to ask for your feedback on certain items. If you're able to, please respond to those polls. Next slide. Right now, I'm going to introduce our moderator for this webinar, Hari Nera from Virginia Department of Transportation, will be our moderator today.
Thanks, Ben. Welcome to the AASHTOWare Pavement ME Design Fiscal Year 25 webinar number 4 on an overview and demonstration of the proposed structure builder and the back calculation BCT tool within PMED. I am Hari Nair, the chair of the Pavement ME Task Force, and I will be your moderator for today's presentation. And today's presenters will be Chad Becker and Dr. Abu Sufyan of Applied Research Associates. This presentation is being recorded and will be available on the ME resource website next week. Again, I am the chair of the Pavement ME Task Force, and Ian Rich of Georgia DOT is the vice chair. The other members of the task force are Ryan Fragapane, AASHTOWare Product Director, Ben Said, AASHTOWare Associate Product Manager, Nusrat Morshad with the New Jersey DOT, Kumar Dave with the Indiana DOT, Dulce Feldman of California DOT, Jason Simmons, Utah DOT, Robert Studler with Maryland DOT, Diana Podboroshinsky she's a TAC liaison, and Tom Yu, the Federal Highway liaison for the task force. We encourage you to ask questions, and those will be addressed at the end of the webinar. And if you have any questions, please click on the QA button to send your questions to the host and the panelist. Directly after the presentation, we will address those questions. Any questions not answered will be responded to separately. Now, Chad and Abu will begin the presentation.
All right, thanks, Hari. You should see the first poll question now, and this is pretty typical of our webinar, so we're just getting an idea of how many folks are attending the webinar and what your affiliations are. All right, thanks very much, Ben. Okay, so welcome everyone again to an overview and demonstration of the proposed structure builder and the back calculation tool within Pavement ME Design. Let me skip over these guys. So the prerequisites for this webinar, just prior experience with the PMED desktop application or the web application for new pavements and rehabilitation design, and then back calculation of pavement elastic layer moduli. So the learning outcomes here are going to be to know how the proposed structure builder functions and learn the benefits of the new workflow conveys over the previous system. And then I'll be doing that part, and then Abu's going to take over, and he's going to go through helping you understand how to use the BCT for pavement rehabilitation design and to become familiar with the contents of the upcoming BCT training videos. So again, the objectives: gain a working understanding of the benefits provided by the new structure builder workflow, demonstrating the functions of the back calculation tool, and then introducing the BCT web-based training videos and topics that are going to be covered by that training. Okay, so the PMED Structure Builder allows users to create designs based on templates that mirror the current design and pavement type selections in the web application and in the desktop application. The goal is to inform and instruct the pavement engineer, provide some guidance as to which analysis circuit, which are the underlying analysis modules and the order in which those run, are going to be run. And then finally, the feature is going to attempt to assist users in the selection of an analysis circuit for the design that they're working on by suggesting alterations to the design to achieve the desired analysis circuit. The Pavement ME Deflection Data Analysis and Backcalculation Tool, that's a standalone software program. It used to be a desktop application that's been deprecated, and now we've tied the Backcalculation Tool in with the web application, and that can be used to generate elastic layer modulus and layer thickness inputs to AASHTOWare Pavement ME Design for rehabilitation designs. AASHTO is introducing a course to train pavement designers and practitioners on the basic concepts of the Backcalculation Tool so that a rehabilitation design strategy will result in cost-effective designs, saving maintenance and rehabilitation dollars. Okay, so the structure builder in Pavement ME Design. I'm gonna jump out of the PowerPoint presentation here and jump into the demo. So I'm logged into Pavement ME Design already. I've just created a new design here called Test 1, and I'm gonna click on the editor. So right away we can see some differences. The general information page has been changed, the structure page has been changed, and some of the materials properties have been changed. Things are going to remain pretty familiar. We're going to get into that, but I want to talk about kind of what the key capabilities here are for the structure builder. The goal is to provide more guidance when designers are working inside of the editor, and to help inform designers of the possible design strategy options that are available to them for a given structure. And then also to help provide alternatives to that structure by adjusting the materials that are being used. So it's a new way to edit the design structure, should be more informative, and it should eliminate ambiguities when selecting a design strategy that we've seen come up through the help desk that people have encountered. Some of the design strategies aren't always clear as to, it doesn't express well what the designer wants to be able to do. And so the new structure builder is supposed to help with that. So with that, let's get a little more into the demo. So again, the general information page has changed. Now it's just going to show the design name, the design life in years, and the unit system. I'm going to come down here to the new structure builder, and I just want to draw your attention to the template section first. And this is going to look very familiar from the previous design strategy selection. So you've got different types of new pavements, different types of overlays, different types of multiple overlays, different types of the new recycling templates. And so the first one we're going to do is we're going to just do a new flexible pavement. So I'm going to click Apply Template here and then just hit Apply. And that's gone ahead and just created a new flexible template. So if there's any aspect of the design that I want to change at this point, I can do that by modifying it from the materials box on the right side here. So if this isn't the subgrade that I want, I can just get rid of that. Then I can go into subgrade and just pull in a different one. And this is all drag and drop. The templates, you just click the button. Both of these boxes, both the templates and the materials boxes, are still searchable. So if I was searching for new flexible here, you can see it's going to go ahead and filter the ones that I have available. And just a little tiny feature here, if you uncheck or unselect rather the tab at the top, now all the templates are showing up in the list, and then you can just do a search against all of them. That way you just have some options when you're filtering the templates there. Okay, so that has created the new structure for me. And one of the neat things about the new system, the new structure builder, is that this has gone ahead and selected the design strategy for me. So it knows that the system has examined the structure, and it knows that I want to do a new flexible design. Okay, so what about cases that are ambiguous? So let's go to an overlay and apply that template. So now the program has created an AC overlay, and the selected design strategy is an empty select box. So I'm going to click on that. And now I just tell the program, okay, I want to do an AC over AC design, or I want to do an AC seal coat or interlayer, and I select the one that I want. And it's going to then populate here in the action menu, kind of with the normal stuff that we would expect for materials for an AC design. So let me go back to structure. I'm going to make one more adjustment here. I'm going to move to recycling, and we're going to do this FDR class A1. And we can see it knows that this template is a new flexible design. So the user doesn't have to guess at what that particular, what set of recycling templates, applied to the new flexible design analysis circuit. Back on the materials page, we can see that for the flexible FDR class A1 layer, the effective binary content by volume default for that layer has been set. All the other defaults associated with this FDR class A1 material have all been set as well. And that leads me to my next point on this structure builder. We do have some additional features that we're going to add to it in FY26. That includes the abilities for users to create and define their own templates, which you would do under your tenant management as a library. And we're also going to include the material libraries in the materials section, so you can load those into your designs as well. If you're another small change, if you're on the materials page, you'll note here that the thicknesses are no longer editable. And that's because these are part of the structure builder now. And so if you click edit here, we've left this button here. If you click edit, it's going to take you back to the structure builder, and then you can go ahead and modify your thicknesses for each layer. Okay, one of the last things I want to show you is this new analysis path requirements drop down. And this table is meant to provide guidance to the users if there's a different type of pavement that they want to build, but they're not able to, they don't understand why the particular structure isn't allowing to build it. One of those that we've bumped into quite a bit is like with new semi-rigid. And so new semi-rigid, in order to build that, it's letting me know, well, in order to build new semi-rigid, I need an AC over CTB design. I need a chemically stabilized layer. So I can come up here to my cement base. I can grab the cement stabilized layer and chuck it in there. And now the program has identified this to analyze the structure and identified this as a new semi-rigid design, and will follow the appropriate analysis path. So it's no longer required to be selected by the users. The program's going to look at the structure. It's going to figure out what design strategy you're going for, and it's going to provide either the only possibility based on the structure or a set of possibilities based on the structure, and then the user can pick the one that they want. And then this table allows you to, if you had questions about a different type of design strategy that you wanted to build, and whether or not it represents a legal or allowable analysis path in the application, this table helps guide you in that direction. So if I wanted to do a new JPCP, I could do that here by just dragging this down. And now it says for rigid pavements analysis, the maximum number of asphalt layers beneath the PCC layers is 1. Okay, great. So that means I just come up here and delete this layer. And now I have available to me new JPCP, new CRCP, or JPCP restoration. And so I can select the actual sort of design information that I want at this point. I know I'm going to build a JPCP pavement, so I select that one. And then again, it loads in the appropriate materials pages for the desired structure. And then the only other difference here is some of the general information stuff that was related to the structure was moved to this page. So things like the pavement construction date and the traffic opening date. If you're working with an overlay, there is a construction separator for that. That gets automatically added in. I think we saw that earlier. I'll just apply a ACAC overlay. You can see that has shown up here. When I select AC over AC, you can see we get our existing pavement construction date and our proposed overlay date as expected. And the same is true for things like multiple asphalt overlays. Throw one of those in. Now we have our original pavement construction date as well as the other construction dates available. And this works identically to the way that it worked in previous versions of the application. So this feature is currently under review. We have some additional meetings with the technical review team to finalize some of the user interface, finalize some of the workflow elements. And the task force has also performed a review of it. We anticipate that if it's accepted by the TRT and the task force, sometime after the user group meeting, we'll make this feature available as the new way to select the design strategies in the system. But we do want to get feedback both from this webinar and the user group meeting as well before we make that decision, because this is somewhat of a large change in the workflow. And so we want people to feel comfortable with it. And with that, I think I can hand it back over to Abu.
So thank you, Jad, for the wonderful presentation on the structural builder. I'm sure this feature will be, the template design will be really helpful for many of us doing design in the PMED. Now let's move on our focus to the back calculation tool, which is a standalone software, as I had mentioned, that can be used to generate elastic layer modulus and layer thickness inputs to the AASHTOWare Pavement ME design, PMED, for pavement rehabilitation design. In this part of the webinar, I will show the functions of this BCT tool through some screen capture that was taken during running an actual back calculation using the BCT. Here are the discussion topics. At first, I'll show how to access or install the back calculation tool. Then I'll go through how to get access the BCT user or the help manual. I will use the BCT user or help manual interchangeably from now, as these two are basically the same document. The BCT app that's also integrated with the web app version of PMED. And then I will show the main user interface and modules of BCT through some screenshots. And finally, I'll demonstrate the step at the same time. I'll demonstrate step-by-step use of BCT in back calculation through PMED. Okay, now let's see how to access or download the BCT. To access the BCT software, you will need a PMED license. The BCT is included with your AASHTOWare PMED license subscription. So if you have a license to PMED, you automatically have a license to the BCT tool. You can also purchase the BCT as a standalone single user license with an annual fee of $1,650. The link of accessing the BCT is provided in this slide. So where is my laser pointer? So if you go to this website, AASHTOWarePavement.org, you'll see there's an option of downloading the legacy desktop version and the documentation associated with it. But as Chad said, we also have a web app version that's integrated with PMED. And if you log into AASHTOWarePavementDesign.org with your credential, you'll see the BCT. And like I said, the BCT, if you go to AASHTOWare website and log in with user information, the BCT icon will show here under the apps, which is on the top of the right corner of the screen. From now on in this webinar, I will only use and refer the web version of the BCT, as this is the version that will be updated moving forward. Okay, so the desktop version of BCT comes with a user manual. And the web version comes with a help manual, and as I said, they're basically the same document. The BCT user or help manual includes a guided process for back-calculating elastic layer moduli in support of rehabilitation design in accordance with the PMED software. The user or help manual includes 4 chapters, as you can see, and 6 appendices. The 4 chapters are introduction. These are brief intro and background behind developing the BCT. The next chapter is getting started. Input your following a difflectometer, which is FW data, and it describes the deflection and layer thickness data. Chapter 3 is a pre-processing and structure definition and module. It describes the individual pre-processing modules in detail, along with the required user inputs, module controls, and information displays. And finally, chapter 4 describes the back calculation and post-processing modules. There are also 6 appendices to the user manual. These are Appendix A. This one provides a brief overview of the rehabilitation design procedures in the Pavement ME design software, which are also discussed in detail in the MEPDG Manual of Practice. Appendix B, this one describes how the cumulative area difference method is used for automatic segmentation of deflections measured along a proposed rehabilitation project or roadway segment. Next come Appendix C, and this one provides the default values used by BCT for various pavement layer properties. Appendix D provides the default values used by, contains a list of layer types used to define the pavement structure within BCT. The material type selection in the Pavement ME software corresponding to each of the back-calculation layer types, for example, AASHTOWare soil classes corresponding to coarse grain or fine grain subgrade are also discussed in Appendix D. And Appendix E, the 5th one, this one overviews and describes the procedure to load deflection and thickness data files, the process of back calculation of the pavement layer moduli, and generate a rehabilitation design file for Pavement ME design. And the last one, Appendix F, this one provides additional details on the methods to estimate the pavement temperature. The flowchart you're seeing here that's displayed on this slide is a guided process for back calculating elastic layer moduli for use in rehabilitation design. The guided process is a 7-step process, and these 7 steps are also 7 modules in the BCT tool. In this part of the webinar, our discussion and demonstration of BCT will be based on this 7-step process and the flowchart you're seeing here. This slide shows the main user interface of the BCT. The functionality of the tool can be broadly divided into 3 phases. The first phase would be the pre-processing of deflection data that includes project segmentation. The second would be the back calculation itself. And third one would be the post-processing of results to generate inputs for Pavement ME design. The interface is divided into several tabs, if you can see here on the left side of the slide. As you can see, the first module, which is the FWD data, and then comes segmentation sensor selection, final segmentation, and structure definition. These 4 will be involved in the pre-processing of deflection data. The back calculation process will happen in the back calculation tab itself. And finally, the post-processing of results to generate inputs for Pavement ME rehabilitation design will happen in the physical features and Pavement export, the final 2 tabs. The modules are executed sequentially, with some recurring user inputs or selections, while others just display information such as charts or results from internally performed calculation. Users can return to any of the previously completed modules to make changes, but can only proceed to the next incomplete module. Let's move on to the next slide. This slide shows the main user interface of the BCT. The functionality of the okay, I think I am on the sorry, I'm on the same slide. Just to reiterate the 7 main modules of BCT. Now let's go to the first module of the BCT, that's FW data. I'll very briefly describe the primary function of this one. After accessing the BCT software, a user or designer will need to access and need to create a new project with the BCT and upload the FW deflection files and layer thicknesses. After opening the program or the app from the PMED website, the first screen you will see is shown in this slide. So to start with, you have to click on the new project button. The software will automatically go to the next screen, which is this one. Now, a designer can create a project file using two different methods. First one is creating a new project. This approach involves initiating the project from scratch, or if you're doing it for the first time. Initially, the following deflectometer file tab is identified, followed by uploading the FW deflection data. Optionally, a layer thickness file can also be uploaded. However, it is not mandatory for executing or running the BCT. And the second option, and you can get to create a project, is the if you have existing BCT project. This method is used when a project has already been created and processed. The existing BCT project can be revisited if you need any revisions or updates to the associated data files and processing parameters. This procedure requires specifying the BCT project name and the associated project file path. And then the first essential step in setting up a project in the BCT is identifying the following with deflectometer basin data. The BCT currently recognizes 6 types of standard FWD file formats. If you can see the screen here, each corresponding to widely used FWD testing equipment and data structures. These standard formats are: first one is the GILS. It's typically associated with data generated from GILS deflection equipment. This uses the .dat file extension, as you can see. Next one is the QAB, associated with data captured by QAB brand deflectometers. This is recognizable by the distinct .fwd file extension. Number 3, 4, 5 are the Dynatest, version V20, which correspond to their version 20 software output. And F20 is their SI format output from Dynatest. It is widely recognizable for standardized international reporting. And finally, the V25 is associated with Dynatest version 25 software, providing advanced data handling and improved output options. The sixth one is the Microsoft Database.mdb format, offering compatibility with various database management systems. Further details and comprehensive guidance on preparing, formatting, and uploading both deflection and layer thickness files can be found in Chapter 2 of the BCT user or help manual that I mentioned a couple of slides ago. Users are strongly encouraged to consult this resource to ensure accuracy and efficiency in project setup and execution. After identifying the location of the FW deflection data and layer thickness file paths, the user will need to click on Create Project. This will be something at the bottom and not in the screenshot. After clicking Create Project button, the next screenshot is displayed in the next slide here. So this slide displayed a summary of the AWD data and other inputs needed for the BCT, which are displayed by numbers on this FWD screenshot. Most of the data gets populated in the BCT from the FWD deflection data file that you'll upload. The user should always check and make sure the data have been populated. The FWD data and other inputs include the first one. There's an error designation. Any errors in the file will be displayed in this location. So if there's 1 or 2 errors, you'll see there's some type of error. All errors must be resolved before the BCT can continue. Number 2 is the FW plate radius. You have to input here, or it will be automatically generated from the file you're uploading. Number 3 is the sensor location. The sensor locations are defined by the X and Y axis coordinate system. Number 4 is a pavement temperature calculation if you are trying to do temperature correction to your data. Number 5 is the test location, temperature, and GPS data. Number 6 is the deflection data. Number 7 is the target FW load that the user needs to input, whether it's 9 kips or 11 kips. And number 8 is a basin characterization. Just to reiterate, most of the data will be populated in the BCT from the FW deflection file that you're uploading. So as mentioned in the previous slide, sensor location data can often be embedded directly within the following with deflectometer deflection data file. In such case, the Backcalculation Tool or the BCT automatically extracts and populates this information into the system. However, if sensor locations are not included within the original FW deflection dataset, they must be provided separately. As you can see here, the users have the option to either manually input this sensor location
or sensor spacing directly into the BCT interface or to upload them through an external file. If manually inputted, the sensor coordinates can subsequently be saved to an external file format that can be used later. This approach allows users to conveniently reuse the same sensor location data in future backcalculation projects utilizing the same FWD file format. The typical standard sensor location, as you're seeing here, associated with various FWD testing protocols that are visually represented on this slide. These sensor positions are precisely defined in terms of their coordinates relative to the loading plate, using an x-axis longitudinal and y-axis transverse measurement system. Users should verify this information to make sure they are accurate and reliable. So sure they will give accurate and reliable back calculation results. To go to the next slide. Okay, so now I'll move on to the second module of the BCT, which is segmentation sensor selection. Segmentation is step 2 in the guided process, and the screen for the segmentation sensor is shown on this slide. The purpose of the segmentation process is to identify how deflections at different locations vary along the project and whether the project responses or deflection basins are statistically different. The items used for segmentation sensors are listed on this slide, which is a screenshot of the segmentation sensors. These items include the sensors you can see here selected for segmentation, the target load or drop number, the basin characterization designation, and the fourth item is the test type designation. And the fifth and the final item here is the lane designation. As you can see, the BCT allows up to 3 sensors to be used in the segmentation process. The BCT user or help manual provides some discussion on which sensor should be selected for the segmentation process. Any of the sensors can be used in the segmentation process. That's allowed in the BCT. The intent is to capture as much information on the response of the pavement and subgrade as possible to understand how to break the project into different design segments. I will not go into detail, but in summary, the sensor under the loading plate and the sensor further from the loading plate should be the 2 of the 3 sensors used for segmentation in most of the design cases. The third sensor selected should be a distance further from the loading plate than the combined thickness of all the bound pavement layers a designer have, like PCC, asphalt, and stabilized layers that exhibit high stiffness. And one more thing to mention here in the segmentation sensor screen, this will show different layer thickness with chainage, but that will not affect your segmentation process. It's just for the information purpose only. Now let's move to the third module, that's final segmentation. This is a screenshot. Final segmentation is a step 3 in the guided process that I've showed. And this is a screenshot for final segmentation that's shown in this slide. The purpose of the final segmentation is to identify areas along the project with different pavement responses. The item used for final segmentation are listed on this slide, which is a screenshot of the final segmentation module. This item include a preliminary segmentation, and the second option is a statistical segmentation, and the layer material assignment for each segment. For the segmentation process, as I mentioned, there are 2 segmentation procedures to identify areas on the project that respond differently to loads. The preliminary and statistical segmentation procedure are also discussed in the Appendix B, as I mentioned, of the BCT user or help manual. When the user clicks on the first button, which is a preliminary button, the locations where the response changes in terms of the area deflection method will appear for each segmentation sensor as a vertical dashed gray line, if you can see, that are shown on the screen. Next is when the user click on the statistical button. The location where the responses, the deflections are statistically different along the project will appear for each segmentation sensor as vertical dashed gray line that's shown on the screen. The user can toggle between the preliminary and statistical segmentation to graphically compare the 2, but will need to make a decision ultimately on defining the limits for each segmentation. Some more details on final segmentation. At the bottom of the screen is a layer structure table. The layer structure table only appears when a layer thickness file is imported into program in the step 1 or module 1 of the guided process. The user must manually assign a material type to each of the layer within the layer thickness file. For this example, 3 layers were identified within the GPR data, and these are an asphalt layer or AC layer, if you can see, a granular base, and a coarse grained soil substrate. Remember, a maximum of 5 layers can be used in the structure simulation in the BCT. The different material types are included in the drop-down screen. The user assigns a material type to each layer. The default layer properties for each layer type are in accordance with the MEPDG manual practice. These assignments are also included in Appendix C of the BCT user or help manual. Now let's move on to the fourth module, which is structure definition. So structure definition is step 4 of the guided process, and the screen for the structure definition is shown on this slide. The purpose of the structure definition is to create the pavement structure for each of the segment, or to review the structure created from the layer thickness file imported in step 1. The item used to relate the structure definition are listed on this slide, which is, as I said, the screenshot of the module 4, the structure definition. And the items are the number of layer type, layer thickness in inches, Poisson's ratio, maximum and minimum modulus that user can input, and a seed modulus. Some things to remember for structure definition: the layer thickness and other information or properties are imported from the other available data inputs from step 1 or module 1. Also, a designer need to reduce the minimum elastic layer modulus to a very low value and increase the maximum layer modulus to a very high value, so that the limits of the layer modulus are not exceeded during the back calculation process. And if the layer thickness file is not imported, all information on this screen needs to be manually entered for each segment. So if you have a thickness file, that thickness will be automatically populated. Next, if you have a stiff layer that you can define as a hardpan or bedrock layer or some very other stiff strata, the user checks the stiff layer button, you can see here. If not included in the layer structure definition, a layer for a stiff layer will be added or replace the lower layer without a stiff layer. So if the user clicks the stiff layer button, the user should check the other layers and make sure the structure definition and layer properties are correct. When a stiff or bedrock layer is included in the structure, the thickness of that layer will show a 0, if you can see here, in the last layer. The last layer in the pavement structure is assumed to be infinity, and 0 here designates infinity. A thickness of 0 cannot be entered for any of the other pavement layers except the last layer. So just to reiterate, if you want to add a rigid or stiff layer, you have to check the box that has a stiff layer. The user also needs to check a layer thickness and other properties for each of the segment. And then when you're happy with your layer thickness and the other inputs, you need to click on the apply button to accept the values included for each segment. For this example in the screenshot here, you can see this specific pavement segment is divided into 3 segments. And for 3 segments, you need to hit apply and proceed to the next step, which is step 5 in the guided process, because the layer structure simulation for all segments have been accepted. And just to reiterate the function of this step, the user needs to check layer thickness and other properties for each of the segment. Now let's move to the as I said, module 1 to 4 was the pre-processing of and the layer inputs, and module 5 is the back calculation process. So now let's move to that module. The user or designer needs to make 2 decisions on this screen or tab. The first is related to the sensors, if you can see here, to be used for back calculation. And the second is to determine whether the asphalt layer elastic layer modulus is going to be adjusted to a standard reference temperature. First, the deflection recorded by the sensors are checked on the screen. Any sensor that should not be used or excluded from the back calculation progress needs to be unchecked from the list here. Unchecking the box for a sensor means the deflection for that sensors are not going to be used for the back calculation process. Sensors that should not be used for back calculation are those with a negative x-axis value for the load transfer efficiency. LT, we'll discuss later how to get LT from BCT. And the second decision is to manually enter the reference temperature when all asphalt layer moduli are needed to be adjusted to the reference temperature. Simply check the box you can see here and enter the reference temperature you need. If temperatures are not included in deflection file, it is suggested that these features don't need to be used. After these two decisions are made, the user simply clicks the back calculate button here, and the BCT starts back calculation process for all pavement layer and segments. And just to reiterate, the function of temperature correction, if pavement temperatures are not included in the deflection file, you do not need to use this adjustment. So this is the screen right after the back calculation is finished. You can see two graphs. The plot in the above, you can see the back calculated elastic layer modulus for AC layer, the base and subgrade. If we zoom in, so you can see the outcome from the back calculation of all the layer elastic layer modulus. Let's see and overview the information included on this screen. First, the results or outcomes are summarized for each segment. You can see this is the first segment. The user simply clicks on the drop-down arrow here for when there are more than one back calculation segment was defined during the final segmentation step. The outcomes for each segment are included in the tabs identified on the screenshot. As you can see, there are 3 tabs, which includes modulus, layer compensation, and bedrock. When the outcomes are summarized, the modulus information always will be shown first. Information or the modulus result include 2 graphs, as you can see, that represent values for each specific segment. The first is the graph of the back calculated elastic layer modulus for each layer in the structure simulation along the segment. This graph appears as an arithmetic plot, but you can change it to a log scale or a semi-log plot, which is shown on this screenshot here. The pavement structure used in the simulation or example included as an asphalt wearing surface, a granular base, a subgrade layer, and a bedrock. So you can select different layer type, and you can see back calculated modulus for each of the layer types. The user also has the capability to turn off the results for any layer. One reason for turning off the results for different layer is when the layer is designated as a fixed layer and the elastic layer moduli are not calculated from the deflection basing. As an example, if you have a bedrock or a very thin layer. The second graph you can see at the bottom is the root mean squared error, or RMSE, for each deflection point or location. The RMSE is a measure of how well the calculated deflection basins fit to the measured deflection basin. The lower the RMSE, the better or closer the calculated and measured deflection basins. The maximum RMSE value that appears in this box here for this example is 100%, just to ensure all of the deflection locations are included on this screen. The user can reduce the maximum RMSE to a specific value. It is generally suggested that 5% can be used in summarizing the result going forward. A large RMSE does not always imply the results are bad. It just means the calculated and measured deflection basins are different. If many of the locations have higher RMSE values, say exceeding 10 or 15%, that usually implies the pavement structures needs to be revisited, or the layer thicknesses could be different, or possibly the back calculated elastic layer moduli exceeded the minimum or maximum elastic layer modulus set by the user in the structure definition screen or step. Now let's discuss the post-processing step. I'll start with the physical feature tab of the BCT. This is a screenshot of the physical feature tab from the back after the back calculation is performed. 2 parameters will be addressed here. First one, the first plot you can see here, the load transfer efficiency, or the LTE, of transverse cracks and joints. And the bottom plot is the loss of support or potential voids or material disintegration of the bound layers. The user first select the sensor to be used in calculating the load transfer efficiency across the transverse joint of PCC pavements or transverse cracks in flexible pavement. Using the long-term payment performance, which is LTPP definition of the load transfer efficiency, the deflection measured at sensor 9 is divided by the deflection measured by sensor 1. And that will, sensor 1 is a sensor on the loading plate, and that will give you the LTE or the load transfer efficiency of rigid pavement joints. For flexible pavement, the trailing sensor or sensor 9 that measured the deflection is divided by the deflection measured by sensor 2, or that is 8 inches away from the center of the loading plate. The BCD program can use all drop heights or target loads for load transfer efficiency calculation, but the user can select just one or all of the target loads. Now let's discuss the bottom picture, the loss of support or void detection. Chapter 4 of the BCD user or help manual includes a detailed discussion of the loss of support variable. But in summary, the loss of support variable is the intercept between the deflection versus load level relationship. Positive values of a certain magnitude will suggest you have potential voids underneath the PCC layer. However, this variable can be used to visually determine how the loss of support variable changes along the segment. Positive and negative values can suggest anomalies or disintegration of mixtures or materials beneath the wearing surface. And finally, it's the final tab of the BCD, which is a PMED export. Now the results have been reviewed and accepted by the user or designer. Let's move our attention or focus on exporting the BCD data for use by the user and creating a PMED file for rehabilitation design. At the bottom of the summary of the result screen, you can see there are 3 feature boxes or action. First one is the export to ME design. So you can export this result directly to a ME design file. And so it will save you some time in the pavement rehabilitation design. Also, you have option to export this as a BCD data. So you can use it later to modify your structure or modify your seed moduli or anything. And third one is the normalized deflection data. So some agencies have requirement to normalize the deflection data to certain load level like 9,000 or 11,000 pounds. You can also do it from the result from here. After the user clicks export BCD data, a zipped file will be downloaded and created as shown in this slide. Excel files are included in the zipped file for each segment. If a user defined one segment, then one Excel file is created. But if a user defined 5 segments, then you will get 5 Excel files separately, and that will be inside the zipped file. So this until now, the part of the webinar we just finished was a very high level, I would say a bird's eye view of the function of the BCT. So if you want to know more details about the usage and process of BCT and deep dive into more of its background inputs and outputs, we are preparing a web-based training course that will be hosted by AASHTOWare. And I will try to give you a very brief outline of these upcoming training videos. Discussion topics of this part of the webinar will be, I'll introduce the web-based course on the BCT. I will state what will be the outcomes and objectives a user can get after finishing this training course. Who will be the target audience of these training videos? How we organize the course and what will be the delivery format? And finally, the course roadmap. Introduction to the training course. The title of the training course would be Principle and Application of the BCT, which is Backcalculation Tool for Rehabilitation Design using the PMED software course overview. The goal of this course will be to train pavement designer, practitioners, and engineers on the basic concept of the BCT so that a rehabilitation design strategy will result in cost-effective design that will save maintenance and rehabilitation dollars of the agencies. And the course focus is on the procedures described in AASHTOW's Mechanistic Empirical Pavement Design Guide, MPDG, 3rd edition. A matter of practice that's specific to rehabilitation design input level 1. Some more of the BCT training course. The course development and deployment are sponsored by the AASHTOWare Task Force on the MPDG, and it is an outreach effort to state and local governments and consulting organizations to provide detailed training on using the BCT for pavement rehabilitation design. This course employs the concepts and procedures included in the BCT of Mechanistic Empirical Pavement ME software. And finally, two primary reference manuals was used for this course. First one is the MPDG Modeler Practice, and second is the BCT User Guide or Help Manual that I mentioned, displaying different tabs of the BCT. Outcomes of objectives one can get attending this course is the user can define back calculation process. The user can describe or how back calculation is used within the ME-based pavement design approaches, specifically in the MEPDG. He or she can define the fundamentals of ability testing, also explain the BCT back calculation procedure and different limitations, list different types of pavement layers and how to simulate them in the BCT app, and define different input levels, like input level 1, 2, or 3 in the MEPDG. Some more outcomes and objectives. After finishing the course, the user or designer can explain the difference between the 3 rehab input level 1, 2, and 3 for PMED, identify the inputs and outputs of BCT that I showed very briefly from last half an hour, and finally describe how to revise BCT inputs to achieve a better or more accurate outcomes. Target audience of this course, pavement, as I said, pavement designers and engineers at the local, state, and federal highway agency level. Consultants and academia that support agencies in carrying out pavement rehabilitation designs in day-to-day practice. And course organization and delivery format. This course was designed and organized in a modular structure. So there will be some specific modules and session I'll show in the next slide. So the specific modules can be delivered individually or they can be delivered together. However, the course can be easily revised to fit an agency's less to more experienced staff or deflection testing and back calculation of elastic layer moduli. The modular structure will give also provide an agency the flexibility to host and deliver the entire course at one time or some selected modules for a specific audience. And the course materials were developed for delivery in a webinar format that then the participants can view at their own pace. The course material, however, can also be used for delivery in a standard in-person environment, instructor-led type or training environment. And this one is the course roadmap, very brief. You can see there are 5 modules. In the module 1, there will be a course introduction. Module 2 will be the details of fundamentals of falling with deflector testing and back calculation. You can see section 1 will be completely on FW deflection testing. Session 2 will be discuss the details of structure simulation, like how a designer can simulate a pavement structure within BCT and how to determine thickness of different layer. And session 3 will discuss the back calculation procedure process itself. Module 3 will be a whole recap of the input level 1 of pavement rehabilitation design using PMED. And the module 4 will be solely using on back calculation and the BCT. Session 1 will be how to access the BCT software, the web app, and the desktop version if you want to use. Session 2 would be a BCT overview and inputs. Session 3 will discuss about different BCT outputs and how to interpret the result. And session 4 would be BCT results for rehabilitation design. And then the course will finish with closing and takeaways. And with that, I am in the concluding part of my part of the webinar. Just to reiterate the summary and takeaways the participant can take from this webinar. First one is what Chad described, the PMED structural builder. This template-based design procedure will allow the user to create design based on templates and assist the designer in selection of an analysis circuit for the design by suggesting different alternatives to the design, so that can be achieved at desired analysis circuit. So in short, you will have different templates that you can select from a catalog. And then we showed a very brief demo of the function of the BCT web app that can be used for back calculation of elastic layer moduli to support rehabilitation design using the PMED software. And finally, I described the web-based training course that will be live soon, hopefully in the next fall. And I think with that, I'll hand over to Hari for poll 2 and the concluding part of this webinar. So the first question to the user is, what type of deflection equipment is typically used by you or your organization? A Dynatest, Coab, Chills, or any other device, or if you do not use deflection basin test, you have to use option 5. The second question you're seeing on your screen is, which backcalculation program do you or your agency use for rehabilitation design? You can check if all of that apply. If you use EverCalc, LMod, Modulus, ModComp, or ModTech, or Meshback, or another backcalculation program. I think we'll wait couple. And one more question you have in the screen, question number 3. If we go, is how valuable was the visibility portion of the webinar to you? This is kind of a feedback type of question. So I think we'll wait a couple of minutes here so that the user can finish all 3 questions.
Looks like a critical mass of folks have participated in the poll, so I'm going to end the poll.
So Hari, if there any question answered to, we can answer now, if there's any question.
No, most of the questions are answered above.
Okay, that's good.
Great. So we can go to the next slide.
Yeah.
Okay. I'm going to give you guys one more poll. Okay, this is a poll to select your top 4 topics from the list below. So you guys heard from us today, our webinar choices, but we would like to hear from you. These are several topics we've collected over the course of several webinars and user group meetings. So the top 4 will be considered for the next 4 webinars of next fiscal year. And then lastly, in relation to our current topic from today, which 3 of the following BCT topics would you like to see in a future webinar as well? As you are filling out this poll, we're going to give you a couple minutes to think about which webinar topics you'd like to see. And while you're thinking of that, also start thinking about the user group this year. I put a link to the registration site in the chat feature. If you go to the chat feature, you should see a chat from me with the link to the registration site. For those of you working at a state agency, you might qualify for travel reimbursement from AASHTO, depending on your license structure. So head over to that website to see if you qualify for that and reach out to me with any additional questions. I'm going to wait one more minute for the webinar topics. Answers are still flying in. I think there's a couple of questions in the Q&A section. We're going to have time for Q&A here after the next few slides. So if you don't see a typed answer, by then we'll get to your question during the Q&A session. I'm going to go ahead and close the poll for the webinar topics. Thank you again for answering those. And if you have a topic in mind that you didn't see on the list, feel free to send it over. to that email on the screen, pavementmedesign@aara.com. Okay, next slide. And thank you for attending the webinar. My contact information is here on the left-hand side, along with Hari. And of course, the preferred customer support line there, both the Pavement ME design@aara.com and the phone number, as well as other ARA staff who can assist you with your questions. Next slide. Just a heads up about additional training that's offered out there. AASHTOW's technical training solution offers a catalog of over 260 courses covering topics from construction, maintenance, materials, pavement design, and so much more. These courses are available at no additional cost to the members of the state sharing program within Technical Training Solutions. So there's a good chance if you're on this call, you work for a state agency, you're a part of this program. You can scan that QR code or go to that store.transportation.org/trainings. There's currently a training course there for the MEPDG. As well, check out our YouTube channel. That's at AASHTOWare Pavement ME Design, youtube.com. Next slide. And because you attended this webinar, please feel free to take advantage of these discount codes when you're reordering or ordering your next round of publications from the AASHTOW store. You can get a 20% discount off of your publications. So I will just hold on this screen for a moment while folks either take a screenshot or picture or write down this code. Okay, we can go to the next slide. Thank you so much. Let's go over a couple of Q&A box questions. Hari, are there any questions in the Q&A box? I see at least one. Maybe we can get a live answer for. And that question is, in the BCT tool, there were two important items: preliminary versus statistical, and initial versus multiple segments. Can you please tell when to use what? What is the difference between those items?
Oh, as I mentioned, like preliminary are the segmentation that will segment your pavement based on the area deflection method, and the statistical segmentation will segment your pavement based on the stretch that is significantly statistically different than the other. So based on those two, you have to use one of them. I think Harold, if you want to add more, you can.
Yeah, I'll expand on the preliminary versus statistical. Abu defined, they are in the appendix on how they're done, but they're just suggestions. The other important item to keep in mind, especially when you have a layer thickness file, the layer thicknesses are not used within the preliminary or statistical process to define the segmentation limits. But that is a very important parameter or variable that the user should consider in establishing the segmentations or the segments. So the information is provided as information to the user, so the user can actually define the segments they want to use as part of evaluating or back calculating the layer data. There may also be site features that aren't related to thicknesses, that aren't related to the deflections themselves, that would provide that we know the user in doing a rehabilitation design would use different segments. As an example, you may have an major intersection somewhere and along the project and have a lot more traffic on one side of the intersection versus the other side of the intersection. And the user may want to use that intersection to define different segments. So those are only suggestions, and the user is responsible for defining the segments to be used in back calculating the resilient modulus and to be used in a rehabilitation design. Okay, back to you, Boo.
Yeah, I think any more question, Ben?
I don't see any more questions, Bo.
Okay.
Yeah, I don't see any more. I'd like to thank all of our speakers, Abu, Chad, and Hari for moderating. Really appreciate it. This webinar, again, was recorded, and we'll be emailing out the recording early next week. So thanks for attending, and have a good rest of your week. Thanks. Bye.